what our internal color measurement task force is doing. So when we talk about this, it's really important that we talk about the people that are going to be working on the color program with you or for your company, because we need to understand their knowledge, um, what they understand about color, what type of color measurements they've done in the past, what type of instruments you're using. All these different things go into it. So when we talk about the key stakeholders, we have the instrumentation, we have the standards and the organizers, we have software, we have data share, and we have data analysis. And all this stuff works together to give you the whole entire elements of the corporate color program. So what I said in the beginning was, how are your people doing? Have you added or lost people? What are your training needs? And then the knowledge of your color team. We're developing some new forms that you can fill out, or I guess they would be like more of a document that you would fill out that would give us an understanding of where you are at currently with your current color program. Or if you do not have a color program, we would be able to help you set up all the instruments and the training needs and everything to set this program up. That's very important. And we also want to make sure that the knowledge of your employees is at the level that we think is needed for them to really be able to use the information they get from our instruments effectively. The other important thing is the IT infrastructure. So our software, when you get it with the instrumentation, how this works is it comes out of the box and you have to use the databases on the computer that the software is installed on. There's also options where you can use a SQL server, and this allows multiple people to access the same data at the same time. And this is really important to make the color program work very efficiently and allowing everyone to have access to the information. So the other important thing with the changing times, there's new raw material suppliers. For sustainability, people are changing the materials that are in the coatings to be more sustainable. And all of this stuff affects how your color is going to look when you spray it on your line. And there's always multiple suppliers supplying into different facilities. So this is also important when we're talking about a color program, because you want to make sure that if you're a supplier, what you're sending to the OEM is on color. Or if you're the OEM, you want to make sure that all the suppliers are in the same color position so that you have harmony on your vehicle. I know that this is an interesting question, but have you had, significant color issues in the past year? This is important information for us to know, because if that's happening, then currently the program that you're using at your facility may not be robust enough, and we can come in and help you implement new processes to improve that. And then the other important thing is that you define your goals. So if you want to maybe maintain your existing color position, this is one goal. If you're trying to improve your color positions, if you have certain colors that are affecting you maybe at the OEM, or if you're an OEM, there's one color that it seems that most people can't not seem to get in a color position that gives you good color harmony. These are all important things that we need to know for your goals for the next year, or this year actually now. So we go back again to all the elements of the corporate color program. And here you see instrumentation is the first one. So for instrumentation, you can have either multi-angle color with effect measurements, or you can have single angle color measurements. So this depends on what you're measuring and what you're trying to accomplish with their measurements. And the biggest thing about these instruments is that you have to have really good inter-instrument agreement. And this allows us to do digital standards, which we'll talk about a little bit. And your reproducibility has to be very good, or else your data is not going to be robust. The repeatability, both short and long term, over a wide temperature range is also important, because when we're measuring either vehicles or parts, we're not always in a controlled atmosphere. So like in a lab setting, maybe we're out on the plant floor or even outside. So it's important that you have repeatable measurements over different temperature ranges. So for instrumentation, if we're talking about your current instrumentation, you need to think about the age of your instruments. If you've been updating them with the current firmware, it's just like an iPhone. If, say, you have an older instrument and you haven't updated it with the newer firmware, there's times when those instruments can no longer be updated, which means they may not work with the latest software. Upgrading is also something that you need to think about, because the technology is always changing. We're trying to make it better. The coding technology is changing. So all these things affect how the instrument measures, and we want to make sure you're getting the best measurements with your instrument possible. I talked a little bit about the firmware, but the firmware is important, especially when you're using the instrumentation with software packages, because if you don't have the latest firmware, you can't always use the newest software. The service of the instruments, we call it certification. This should be done, we recommend, for plant used instruments once a year. If it's in a lab setting and you're using it not as frequently or not in maybe as dirty as an environment as a plant or plant environment, then you could do it probably every 2 years. And then always there's procedures that need to be written and documented so that everyone's doing everything in the same way. Our software is also set up to be able to give you reports that are specific to your company. And I think that's very important. And then we're going to talk about the instruments right now. So there's 3 different styles of instruments for color. There's a sphere, a D8, a 45-0 or a 045, and then the multi-angle that can either come with or without effect measurement. So for the first 2 instruments, the sphere and the 45-0, if you look at this panel, this is one panel. One half of it's grained, the other half of it is ungrained. And if you look at this panel visually, you can see the difference immediately. The structure looks a lot lighter than the glossy side. And if you are going to measure it, you need to understand what the different instruments will measure and what it will tell you. So for the 45-0, this is usually used for harmony or batch-to-batch control. Usually for solid colors, not for metallics, because metallics have color changes on different angles due to the metallic in the formula. And this is a problem. Sorry, dog barking. This is important for when you're measuring solid colors, that you're just using the 45-0 angle, especially for interior automotive applications. Here's the 45-0 data from the 2 panels that we just looked at. So on the matte or the textured surface, you're getting a different reflection than on the matte surface. So the 2 panels, if we measure with a 45-0, this is what we call measure as we see it. So that would match your visual impression. It's going to give you 2 different evaluations of that panel on the glossy and the matte surface. So if we go to the sphere instrument, or the D8, this uses the diffuse illumination to take the measurement, and the color differences do not always match what we see visually. So for the panel that you saw previously, the two measurements would be exactly the same. So these instruments are usually used for color matching. So if you have like a pellet supplier that's sending you in material, but the panels don't always have the same gloss level, but you just want to make sure the material in the pellet is the same, then you would use a sphere. We also use these for weathering studies. So this is the two sections of the panel that we measured with the sphere geometry, and these two match exactly the same from both instruments, or from both sides of the panel. So this is the two, so the 45-0, we would measure as we see it, and that would give us a delta E between these two sides of the panel of 3. And for the sphere technology, which is diffuse illumination, your delta E for these two sides of the panel would be 0. So now we need to talk about the multi-angle. So for our instrument, we have minus 15, 15, 25, 45, 75, and 110 angles that we measure. The minus 15 is usually used for color changing pigments. They used to have some chromaflare pigments in some of the Mustang colors years ago that caused it to change from like green to purple or blue to yellow or something like that. That's when we use this minus 15 angle. But even for solid colors for exterior automotive, we recommend using the 15 through the 110 for all the colors because it gives you more information. And some of the newer solid colors, even though technically they're not traveling, we've seen with the different pigmentations that are coming out that they're starting to travel even on solid colors. So it's important that you understand all the different angles and how that's going to affect your harmony on the final vehicle. Then we have sparkle, which is direct illumination. This gives you an idea of the flake characteristics of the material. And then graininess is diffuse illumination. And this also helps you with the flake characters of the material. So we're going to talk about effect in a little more detail. So like I said, the sparkle is direct illumination. And in the picture, you can see a high sparkle and a low sparkle. And then the graininess is under diffuse illumination, like under a cloudy sky. And this gives you this grainy pattern. So on the left side, it's a larger flake because the separation between the flakes is bigger. And you can see the flake size is bigger. And the one on the right is finer. And the flake size looks much smaller. So again, the viewing conditions, direct spotlight for sparkle numbers. And this gives you an idea of the reflectivity of the pigment, the amount of the effect pigments, and the size of the flakes themselves. And you need to use this in combination with graininess, but I'll talk about that in a little bit. So here's graininess. This gives you an idea of the flake size. Also, if you have disorientation of the flakes. So if you spray something really wet, your flakes are going to have a tendency to maybe float a little bit in the material, and that's going to give you a different orientation of the flakes for graininess, so you could have a different look. And then agglomeration of particles, which no one wants. This is where the pigments actually stick together, and it gives you like a spotty looking appearance, like under that high graininess picture that you see on the left. So for sparkle, we have two things that go into the sparkle number, the sparkle area and the sparkle intensity. And it's important if you have an issue with sparkle that you look at these two numbers because they really give you an idea of what's going on with the flake inside the paint itself. So sparkle intensity, I think, is pretty self-explanatory. So if something has a brighter or lower flashback to your eye, it's going to pick that up under sparkle intensity. And the sparkle area is basically how much of the area we took the picture of is sparkling. So you could have, say, a low concentration of a large flake or a high concentration of a small flake and end up with the same sparkle area if you had it all figured out correctly. And so you really need to use the graininess to make sure that it's the same flake size. So graininess is one-dimensional. 0 would be a solid color, so no flake at all. And then it goes up to a scale of 15. So why is this important? So when we look, we did some visual correlation studies for sparkle and graininess with many customers in Europe and looking at several panels and different colors, and everyone decided the correlation in the end showed that there was a 0.5 difference that people could see visually. So in this example, if we just use the color data, which the delta A or delta L, delta A, delta B, all those numbers look pretty good for color. But when we look at the sparkle and the graininess numbers, the sparkle 15 is at on one panel 6.9 and on the other panel 1.3. This is a significant difference if we're talking about what you can see as a 0.5 difference. So obviously the color numbers aren't taking into account everything that's looking like in the coating, because if you saw this on a vehicle, you would not like this panel versus the other panel. And also the graininess is quite different, 9.5 to 6. So you would see that difference also. So standards and organized workflow. Under here, we have digital standards, standard management, and organizers. So this is all about making sure that you're using, everyone who's painting that color is using the exact same standard, the exact same procedures, the same equations, the same light source, all these things. So this is very important in having a corporate color program where you want everything to be uniform. So digital standards are only possible with really, really high inter-instrument agreement between instruments. So the BYK-Mac, all of our instruments, the Spectre 2 guide, which would be our sphere, our 45-0, we do a lot of work to make sure the inter-instrument agreement is high on these instruments so that we can do digital standards. So the way we set up digital standards in SmartChart is that they're emailable. So you can, your OEM or your other suppliers can send you the digital file that they're looking at, and you'll have exactly the same information that they have in evaluating your color. You can lock the tolerances. So if you're using, say, 45-0 and a observer of 10 instead of 2, you're going to see a difference there. And that's just the things that we can lock down in standard management. And we can use them for multiple customers with the exact same spectral curve and target values. The other thing that's very important is your sample preparation. So when you're measuring your digital standards, you want to make sure that everyone's doing them the exact same way, especially for the instruments that are directional, like our BYK-Mac, because the directionality of the light source is going to change how it measures the panel. So we have certain ways that we set up for sample preparation before we measure a digital standard. And then if you had changes in supply chains and you need to redistribute your standards, it's a lot easier to remeasure a standard and send it digitally than to have to send panels to everyone. So in standard management, here you can define all the parameters for the color. You can set up your pass-fail criteria. We have a lot of customer specific scales that we've put into Smart Chart because customers want to be able to just click on their scale and have all their pass fail and their equation and everything preset. And then, like we talked about numerous times, you can send and receive the digital standards through email, no problem. I talked about this in the beginning, but the software with the SQL server is important. And this is our Smart Chart software. So in here, you can set up 2 SQL servers, one to have all your standards and your organizers, and the other to have your measurement data. And then every time you update your standard management with a new standard on one computer, all the other computers are going to have that exact same standard on their computers, as well as be able to access the measurement data from any computer that has Smart Chart. Here's just some of the OEM developed equations we've done with the OEM. So Ford, GM, BMW, Volkswagen, Audi, Chrysler, Kia, and Subaru, everyone has their own way they want to pass fail and what they want to use for process control and for harmony. So the thing about our software is we always have new features and new functionalities that we're developing based off of customer feedback. We always update the OEM equations with the delta E calculations. We can standardize their reports for different templates, and we can always do the training for your needs on new features and functionalities. So data share, this is something that we developed with some of the OEMs, and especially helped during COVID because we could share the data virtually and not have to be there on site to actually see the vehicles themselves. So it was a proactive predictive tool is what we want to call it. And here's some examples of how it works. So the biggest thing that I think is important in here is that you're sharing the data from the OEM side and the supplier side, and everyone has the same ways to be able to view the data in their software at the same time. So this is an example of what you can do with data sharing. So it's a body, the left fender, and a fascia, the left fascia. And you compare these two in Smart Chart, even though the fascia is still at the supplier and the body's at the OEM. And I can predict if this is going to match visually when the two parts come together, or if I'm going to have a problem and I need to make an adjustment. So this would be prior to them even shipping the parts to the OEM. You would already have this information. And again, like I emphasized about sharing the data, transparency is key. Everybody wants to know what's going on. And I think when you come with that approach, that people are more apt to share their data with you because they're really trying to fix the problem and not just trying to blame someone for the issue that they're having. And it can impact the profitability, so you can get better harmony and quicker harmony, and also better reproducibility and repeatable results for multiple facilities. So now we come to data analysis. So in Smart Chart, we talked about organizers. This is just an example of an organizer that we created, and it's just measuring the front of this vehicle. And there are single dots, the yellow and green dots above the second blue line. That shows you match to standard. And then the double dots actually show you the harmony match. So it's measuring the fender versus the fascia. So the fascia versus the fender. So the fender is the second standard that we're measuring against, because even if we're all off to, which we don't want to be, but if we were all off to the actual digital standard, but we still had harmony on the vehicle, then the vehicle could ship. Even though after the vehicle ships, we need to understand why we're not on the tolerancing of the standard, but at least the vehicle can go to the customer. And here's another example of an entire body that we measured. And these different shapes that we have there are so that if you have to print on a black and white computer, you can still see what these different dots are, because they're different shapes and different colors. And here is an example of a trend over time. So we have the blue dots are batch. The red dots are body, I think. And the yellow dots are the fascia. It's very hard to see on my screen, sorry. But you can trend your batch data versus your body data versus your fascia data to make sure that everything's in harmony. And I know sometimes the batch data may have a slight offset, but you can trend this over time to make sure that where your batch is coming in is producing the same color position on your line. So for data analysis, we want to always make sure we visually evaluate the color also. And we want to make sure that we're evaluating under all the different standards, and that the light booths are certified. And we want to make sure that we have the correct lighting to make sure we're verifying the visual to the numeric, because that's the most important thing. So if visually you don't like something, numerically it should show up as a fail also. And that's why we develop new color equations all the time with the industry, trying to make things match better to what we perceive visually. And with the increase in technology, this also helps us match closer to what we see visually. So the biggest thing that people ask us is, what angle are we looking at? And it's important that you always understand where the light is. So in this example, we're in Munich on June 21st, 2010, and our angle of incidence 61. In Detroit, it would be 70. In Shanghai, it would be 82. And for those three different ideas, we're looking at three different angles. So for Detroit, we're looking at, say, the 25. For Shanghai, we're looking at maybe the 75. And for Munich, we're looking at the 110. So if one of those angles is off numerically, then I'm going to see that visually depending on where I'm at in the world on that same date and time. So it's important that you understand what angle you're looking at and how that's going to affect what you're looking at numerically too. The other impact that you have is when you're looking at horizontal surfaces. If the sun is behind you, you're looking at the 75 or the 110. And if the sun's in front of you, you're looking at the 15 or even the minus 15. So very important to know where the sun is. It will help you understand the visual correlation to the data. So what's important when you're doing your evaluation outside? The time of day, where you are in the world, and the time of year, because depending on the time of year, the sun's going to be in a different location depending on where you are. So the other thing that's important is people a lot of times stand in like a semicircle around the vehicle looking at it, and there'll be different people of different heights. And so we're all now creating another variable and not all looking at the same angle because someone is taller or shorter than the other person. And then also the influence of vertical panels, horizontal panels, and the mounting orientation of the add-on parts. So some parts don't fit flush to the body, and you're going to get a variation there. just because those two angles won't be the same. So it's just something to be aware of. There is a possibility of doing light rooms, especially in Michigan where we can't always go outside to look at the vehicles, but it's important that you know exactly what angle you're looking at. So for this example, there's a place on the floor where everyone should stand to make sure that they're looking at the correct angle on the vehicle. So the observer moves, not the light source. And this is kind of how it works in our, well, that is how it works in the instrument. So you want to maintain this specific angle so that you're looking at all the specific angles. And this just shows you another example of this. It's all fixed illumination at 45 degrees. You can look at the whole entire vehicle, and the observers can move around the vehicle to look at the different angles. And like I said, you'd have like specific spots on the floor where you would stand to make sure you're looking at the correct angle. We do have light booths that we can put in for these whole viewing rooms. You have different configurations you can set up depending on the size of the vehicle. And this is the light booth that we recommend to use for these light rooms, because this matches more or the most closely with D65. So what you're seeing outside. And these are just all the standards that our light booth follows. So obviously everyone's using D65. It depends on the OEM, which illuminance they want to use for metamerism. The levels of illumination, this is a lux level, are fairly similar for all the standards. And then the important thing on here is that you use this matte neutral gray background, because that's the best background for not affecting the colors from the background color. So if I have like a blue background, everything is going to look slightly blue. If I have a red background, same thing. This is why when you go to color harmonies, a lot of times they tell you to wear neutral colors so that you're not causing yourself to see maybe more yellow because you have a yellow vest on or something like that. So here shows you the CIE illuminant for D65, and then our D65 for BYK Spectra Pro, and it is the closest to the CIE illuminant D65 out of all of the instruments that we've seen in the past. And it also takes out the peaks from the fluorescent bulb, and it makes it more of a straight line across, which matches more what you see visually. So again, for multi-angle, we have all these different angles. So if you're looking in a light booth, how are you going to look at these angles? So if we have the standard setup for an overhead luminaire, how do we define these viewing positions? And in automotive and most of the color world, everyone uses terms like flash, phase, and flop. So what does that actually mean compared to the instrument? So when we're looking at the face, where the viewing angle is 45 degrees. And the one thing that I need to make sure that you're aware of when we're doing this in a fixed light, we're actually changing the illumination source and the viewing angle. So it's not as simple to tell you what angle you're looking at, because two things are changing. Here for the flash, you're actually looking at the -15 angle if we hold it in the normal flash position, and you're getting a 10-degree illumination. And then if we're looking at the flop, now our illumination angle is 25, and we're actually looking at the 75 for the viewing angle. So here the visual evaluation with the face flop and flash is not completely correlating to what we use in our instrumental evaluation. And again, this is because we're not just changing the viewing angle, which is what we do in the instrument, we're also changing the illumination angle, which in the instrument that is fixed. So we do have a BYK Spectra effect booth. This does multi-angle color and sparkle. And this booth, you can change the angle by changing the table. The illumination angle does not change because it is fixed to the table and it moves with the tilting of the table. So it gives you the 6 different viewing angles with the controlled daylight illumination for 45 degrees. And this correlates very well with our instrument. And a lot of customers, when they look at their panels under this type of viewing conditions, they notice a lot more of what's going on with their materials than they do under the conventional fixed luminaire. So this is the inside and it shows you how it works. So the whole table tilts and your viewing stays the same, but the tilting is changing and that's changing your viewing angle. And the illumination is fixed at 45 degrees. So again, we use really bright LEDs for the sparkle for this because you need direct illumination and it does 15, 45, and 75. And this gives you a really good idea of how the sparkle looks for these different angles. And here's an example. You can also change the intensity of the light if you need more or less intensity to see the flake in whatever color you're looking at. So the BYK Spectra effect, we have, new pigmentations coming out, glass beads, different types of flakes that they're now coating with different materials. There's a lot of stuff going on. So sparkle is one of the biggest problems that we see in the industry right now, is that in order to make your harmony on your vehicle, you need to evaluate the sparkle and the graininess numbers with the color numbers in order to get the best harmony possible. So that is all we have for the presentation. And then I'm sure Greg has some comments. Maybe I missed something. So Greg, you want to unmute yourself and.
No, just the only thing was in closing, making sure that you have ongoing training set up so that when you have new employees, you can onboard them and you have a training path for them to fit into your internal and external networks for color measurement and analysis.
And like I said before, we are developing some processes so that you can self-evaluate yourself to see where you are at with your color knowledge and things like that, and then send it back to us and we can recommend a training program for that, or changes in instrumentation, or other things that we would recommend that would help you get your color program started or ongoing color program continuing. But I mean, the training is, I think, one of the hugest things. I mean, also the instrumentation is important. I talked about that some, but really the training is the key. So do we have any questions, Sherry?
We do. Thank you, Ray, for that presentation, first of all. We do. So would you please define harmony as it was used in this presentation? There was a slide that some manufacturers were using sparkle and graininess for process control and some for harmony.
So harmony is the parts that are adjacent to each other, that match up to each other, and maybe come from different suppliers or even different substrates, that those two panels that match up to each other, whatever they are the same color. That's how we define color harmony.
So just to add on to that, Ray, there's industries like appliance where they will have plastic parts. They'll have parts that have been powder coated and also coil coated. So you've got three different formulas coming together. So you want to have those all look the same, and then you don't want to see metamerism if you look at things under different light sources.
And metamerism, especially for automotive too, but also for appliances, is a big deal, because you could be in your kitchen with the sun shining in, or at night with your lights turned on. And if you have metamerism between two parts, you're going to see a difference depending on what light source you're looking at. So metamerism is a big thing. And also, like Greg was saying, that there's multiple materials going in, multiple paint coatings. Sometimes the substrates are more difficult for people to manufacture than other substrates, and so those are a little more difficult to paint. So to get that color on is not also a problem. But the basis of everything is that you still want to go back to that digital standard, no matter what material you're putting on the parts, because you want the harmony to be good in the end.
We do have an add-on before I get to the next question. William, if you could let us know if we answered your harmony question, but we had the question, what is metamerism? And even I know this one. I will say what I think the answer is, and then Greg and Ray can
Okay, go, Sherry.
Metamerism is when you look at something and it changes color under different light sources. For example, my mother was sending me pictures of her new couch last night, and she kept saying, really, it's gray, it's really gray. And the picture that she sent me, it looked blue. And then she sent me a picture of what it looked like in the catalog. And then she sent me another picture that she took. I think she opened her blinds or something. And so therefore it did look more gray. It could have been her camera as well that she was taking the picture with. But that's what metamerism is, as I know it to be.
Yes. And the problem happens, it's okay if everything is the same material. And if you have metamerism and everything changes color under a different illumination or a light source, that's fine. But it's when you have some parts that have metamerism and some don't. So now some are changing color and others are not. So now you're having a problem where things aren't matching under certain lighting conditions. That's where it becomes a problem.
You probably notice it a lot if you buy a brown or green pair of pants and you go outside and that brown or green now becomes kind of a different color depending on where you're wearing it or what store you bought it in.
Or two different blacks. Yeah. It can happen with clothing also.
So another question that we have is, will grain sparkle color numbers shift from different applicators? Like if one technician sprays a different pattern than another, and if it is not automated?
Definitely a potential for differences when you're applying coatings in a different way. You're changing the orientation of the flake. So that would definitely affect your harmony. And that's one thing that it's important to measure different operators and how, depending on how they spray, so that you have all the data to see how much variation you're actually causing because of your variation in your process. So that's definitely very important.
Because part of that was even if the film thickness matches, like the orientation of the flakes, which I think you mentioned.
Yes. Yeah, even if your film thickness is identical, like we even see it on the bodies of vehicles from maybe like the fender to the door, where it can change because of how they're applying that material. And it's not changing over time on the fender or the door, but it's changed between the fender and the door. So it is very important how you process your parts. You want to do them the same as consistently as possible.
Are there any other questions that anybody would like to put in the chat today?
Craig, I'm sure you have some good story you can tell us.
Well, just to follow up on the metamerism concept, what's changing is the spectral curve of the color. And I bring that up because of the supply chain issues that happened in the last couple of years with COVID and everything. There was a lot of colors that were rematched or re-standardized, if you will. And that changes the spectral curve. So when we're looking at potential metamerism and you look at the spectral curves, if they cross more than, if you're looking at two samples or a sample and a standard and they cross more than 3 times, then you have metamerism. Now you just have to find out which light source doesn't match. And it could be more than one light source doesn't match. It's all dependent upon what the curves are doing. So a lot of your raw material suppliers, your paint suppliers, your plastic suppliers, ink suppliers, they pay a lot of attention to spectral curves just for that, for those cases when they're trying to reformulate.
Ray, you had mentioned wearing neutral colors when using a light booth. What is considered a neutral color?
Grays, tans, even white's not good, right, Greg?
White's okay, but gray is the best. So, like, for the same reason you have the neutral gray interior of the light booth, you don't want anything to influence what it is that you're looking at, the color of what it is that you're looking at. But it happens. So just be aware that if all of a sudden you're looking at something and you know you have a red shirt on or a red sweater and your visual now looks redder, but your data says maybe it's neutral or even greener, it could be an influence from what you're wearing.
And we have at one OEM a big blue wall. And when I went down to look at the color harmony, everyone was looking at everything in front of that wall. And everyone kept saying everything looks bluer than it looked inside. And then I said, well, it's all reflecting off the wall. They're like, oh, good point. So now they don't do that anymore. So it's actually very important, the surrounding colors, when you're looking at things visually, it really does affect what you see with your eye.
And age is also something that you have to be aware of, because as you age, the lens on your eye turns yellow or becomes more yellow, and it can affect how you visually see something. I've seen it where two groups were evaluating a neutral color, a tan, and the one group called out that it's always yellower, and the other group saw it just the opposite, as bluer.
And these things, as long as you're aware of what's happening and you know that you see things maybe yellower than other people, you can take that into account when you give your visual assessment, but you need to be aware of that.
There are tests that you can run on the people that you have involved in your color program, and if they're doing critical color matching, you want to use a Farnsworth 100Q test. It's a standard in the industry. And other than that, you can use, if you're just looking for color blindness, there's books out there. Most popular one is the Ishihara plates, which allow you to quickly evaluate somebody for color blindness.
And interestingly enough, we've had some color people that have had deficiencies in color, different types of color blindness. So it happens. And again, a lot of times, if it's not that bad, you can train someone to overcome it. But some people just can't see the difference between red and green, and they just cannot see it. So it's important that they have those abilities when you're picking someone to do your color.
Could you just mention again why inter-instrument agreement is so important for digital standards?
So originally, before we came up with the inter-instrument agreement that was so high, what they were having to do was send all their instruments into, and Greg probably has better understanding. This is kind of before my time, but they're sending all their instruments into one facility and then setting up a way to figure out how different they were from each instrument, how it was different from the other instrument, so that they could kind of coordinate the data so that it would be the same when it came back into the OEM facility. But that was, what was that called, Greg?
That was what we refer to as trafo mode, and that was the ability to program offsets into software so that you can take into account differences between instruments or differences between standards. So that is solved today by using good inter-instrument agreement, instruments that have good inter-instrument agreement, and then using a digital standard so everybody's shooting for the exact same spectral curve, or spectral curves if it's multi-angle.
And it's really important, like, because especially in automotive, what was happening was you would be a supplier, you would supply different plants, and every plant kind of had their own color position that they like to run to. So as a supplier, you're not going to run one can of paint for plant A and another can of paint for plant B. So you try to just kind of get somewhere in between, which makes everybody's color harmony not so great. But that was kind of how everything was done. So with digital standards, it's no longer the plants that are dictating the color position. It's coming from corporate, and everyone has to go to the same place. So I think that's really key with digital standard, because it does help the suppliers and the OEMs get better color harmony at all plants, not just one plant.
And it's important to remember that with a multi-angle application, when you're using effect pigments, the effect part of the color is integrated into the color measurement at that given angle. So having the ability to separate out sparkle and graininess and have that be in addition to the spectral curve or the color portion really allows you for a much better chance to target and get on target and have good harmony on a vehicle or something that you're making or from batch to batch.
Are there any other questions today? Anybody else wants to talk about? It can be on a different topic if needed. One feature that I thought was interesting, and glad that we kind of take this into consideration, the fact that we use shapes in our software. Therefore, if you wanted to print it out in black and white, you can see what's sort of going on in those graphs. I thought that was a nice feature. I don't know if everybody does that, but I learned
we actually added that because people were printing them off to take them to the color harmony, and then they didn't know which dot represented which part because it was black and white. So yes, we changed that. I don't know if anyone else does that in their software, but we changed that specifically for customers for that. That was one thing that was customer feedback that we modified the software for, which we try to do anytime we find something that multiple people are asking for. We do try to update the software with that information so that it's better for everybody.
And if anybody has time and wants to join us tomorrow, we do have our office hours tomorrow, which is on color theory. Office hours is done a little bit differently. It's a little bit short presentation and then gives time for really some questions and answers and interaction with the group. And we usually do those once a month, as well as one of these webinars once a month on different topics. You probably, when you signed up today, you received the email with all the invitations that you can click on as many of those as you want and sign up. And then our office in Europe also puts webinars on our website to do worldwide. Our applications specialist, Noah, will sometimes do those, or someone from our applications team in Europe as well. And you're welcome to sign up for any of those. They're all free. We're happy to have you. And you're welcome. Go ahead.
And the recordings.
Yep. The recordings are on our YouTube page, which I had posted that sort of in the chat. You will get the recording of this webinar. What else am I forgetting? You can always reply to any of our emails or to our webinar emails if you have a question about anything. Typically, I will get those. I'm Sherry. I'm sorry I didn't introduce myself in the beginning, and I'm part of our marketing team. And I'll do the best I can to get you to who's the best person on our team to help you and assist you with your questions or orders or service or anything that you need. With that, if I don't see any other questions coming in, we'll give you back a couple extra minutes in your day. Again, thank you for attending, and I hope you have a good afternoon and evening.
Thank you, everyone.
Thank you.